morning! Hail Caesar Horatius and all his subglorious subjects on this wonderful sunny Roman day. Good morning all! We are here to learn about the maths of Rome, and I am sitting here definitely not wearing a purple dressing gown or with an olive wreath wrapped around my head with sellotape, because that's how they used to do it in Roman times. We are going to be learning about the number system in Rome. We're going to be learning about a bit about maths from Rome, and we're going to be learning about Roman currency. So with all that to cover, we haven't got time to mess around here. Let's go. So what can I tell you about Rome? Well, before we can do anything, I guess we want to go over to my slides. So, what can I tell you about Rome? Rome is a wonderful, wonderful place. But before I tell you about Rome, we always start our lessons with some greetings from the Earthlings. Earthlings? I don't think the Romans were aliens. We're going to start with some greetings for you. While you do that, we have a number activity. It's a thinking starter activity. All you need to do, like yesterday, what is the odd one out and why? So, come up with as many ideas in the chat as you can. I'm going to say hello. I'm going to say hello to Paul. I'm going to say hello to Sharanya. I'm going to say hello to Amber. Good morning, Grace. Good morning, Fayal. Good morning, Jules Francis Sinclair. Good morning, Tom345, who is in my form. Good morning, Alicia. Good morning, Siddy. Good morning, all. Have I done it again? No, I have the mic on. So it's not me this time, I'm afraid. If you can't hear, that I'm afraid is yourself. You need to unmute your mic and turn up the sound. So, how are we getting on with these ideas? Have we got any ideas yet for the starter? What's going on? What have people come up with? I can't see any ideas yet in the chatting, but I'm keeping my eye open. We've got a few more minutes. If you're watching this and it's not live, feel free to pause it here and come up with as many ideas as you can. Remember, to be a good odd one out, it needs to have something that two of them have that one of them doesn't. So we've got an idea from File, the dollar sign, because the other two have hands. Oh, I like that one. I don't think of the dog as having hands, but nice. Thomas. Oh, of course it's Thomas. Dog and dollar. Why the dog and the dog? The money's the odd one out because clock and dogs have hands. A nice one. Any other ones we've got here? Okay. We're still just thinking of what we're doing. So the bonus prize here was for the dollar and dog both begin with DO. That is correct. If anyone came up with my bonus prize answer, the prize answer was the dog is the odd one out because you can't waste dogs. You can waste time and you can waste money, but you can't waste dogs. But I'm sure there's lots of correct answers. Well done for all those people who came up with something that two of them had that one doesn't. So we're going to be talking about Roman maths. And I'm going to be trying to tell you a whistle-stop tour in 20 to 30 minutes of all the things I can about the Roman maths and how we live here in Rome. Because I'm back in the old times, I'm guessing. So, actually, Rome didn't do much for maths. If you look back in history, the Greeks did loads for maths, and the Romans did loads for engineering and for building and for all those sorts of things. But actually, they're not famous for any maths. You can see here a statue of Julius Caesar, who has a baby attached to his knee. I believe all emperors had to attach a baby to their knee. It was kind of a thing that they did in those times. I'm not sure about that. I might have made that up. But they weren't really famous for much maths, except for the maths we're going to cover today, which is how they did maths. They did quite simple maths themselves. However, they didn't count like we do, using a decimal system. They used a system where they had different letters, and each letter stood for a different number. What they had to do is they had to count by knowing all the different letters, and we are going to look at how the letters translated into the different numbers. If you've already downloaded your sheets for today, you'll see that there's some things to fill in. But here is the information that we used to use. I say we because I used to be Roman, obviously. So here you can see some Roman maths being written out. And these are the values we've got. I, V, X, L, C, D, and M. They were 1, 5, 10, 50, 100, 500, and 1000. So what they used to do is, instead of having the numbers like we have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., they used to use numbers grouped together. So a series of 1s, or a series of 5s, or a 5, a 10, and a 50, a 5, a 10, and a 50. A 5, a 10, and a 50 would be 65. So these are the numbers from 1 to 20. And you can see they're just grouping them together until they get to 4. At 4, they goes IV because it's 1 less than 5. 5 being that. Same with 9. If you can see, 9, it's 1 less than 10, which is why it's IX. Whereas in 8, it was VIII. 5, 1, 1, 1, which is 8. The same here for 14. XIV. X is 10, and then because the 1 is smaller than the 5, we take it away. If the number is smaller, we do a takeaway. So XIV would be 10 and 1 less than 5, which is 14. And we can see the last lot, and they are on their way, and we can see that 19 is going to be the same. You may have noticed a pattern there. It's 4, 9, 14, and 19 that have these takeaways. A lot of the others didn't have, none of the others had takeaways involved in them. Okay, and you'll notice at the bottom it says that MMXX, that's 2020. So 2 M's is 1,000 and 1,000, and XX is 10 and 10. So that's 2020. That's what current year it is. So that's a little bit about how the number system works. And in a second, we're going to head over to my whiteboard, and we're going to look at doing some different things about that. So hopefully you've joined me, and we can see. First of all, we're going to look at how we can put together a big number. For example, if I wanted to put together D, C, L, X, X, I, we need to work out what that number is. And the way I'm going to do it is work out 500 and 100 and 50 and 10 and 10 and 1 and 1. And then I'm just going to add them all together. Remember, you can make that table to use when you're doing the worksheets yourself based on the slides from a few times ago. I might even go back at some point and let you see those. So we're going to go add them all together. I'm going to write them all down underneath each other because that's how I add together. I want to always show my working. Sort of some brilliant work being sent through by email, but I did say that we must show our working for that work because it makes it clear how you got it. So this number is how they would write 672. DCL XXII. So we can do it the other way around. How are we going to write 48? Well, to write 48, we notice we've got a 4. Remember, 4s and 9s are the numbers we need to pay attention to. So to get 40, I think we need 10 less than 50. So I'm going to put XL, because XL is 10 off of 50. Because it's smaller, so we take it away. Then I want 8, so I want VIII, 5111. Notice that this whole bit there is 40. Therefore, clearly, if XL is 40, I must wear size 40 clothes. I'm not sure that's how it works. But there we go. We can turn numbers into letters and letters into numbers. So, if we go back, I need to stop saying so. I'm getting better at it. So when you're losing these numbers, you can only use V, L, and D only once. So you'll only ever see those once. But the other letters you can use up to 3 times. The I's, the X's, the M's, and the C's can all be used up to 3 times. And you'll notice in some of these, C's. Oh, there's 3 C's and there's 2 M's and there's 2 X's and there's I's. So the M's, the C's, the X's and the I's can be used up to 3 times each. You can never use a number 4 times. That's against the rules. So this is what I was talking about. We subtract values, I, X and C at the left. So that means IV is 5 minus 1. IX is 10 minus 1. XL is 50 minus 10. XC is 100 minus 10. So that's how we do 40s, 90s, 4s, 400s and 900s, using a subtraction first. Here's the C one, look. CD is 400. CM is 900. So here's a challenge for you. Whether you're doing this live or whether you're doing this in the future times, which is going to be difficult because I'm in the past already, so you'd be doing it in the future where I'm in the past, so you're coming in the future to do something from the past. I don't even know. My brain explodes like when I try and do that. All you've got to do is pause the video if you're doing it another time, or write these down. If you don't want to know the answers, look away now and I won't read them out. I'm going to show the answers on the screen, but you can look away now if you want to just note down the question or pause it. You can note down the questions and then you can come back and do this yourself and see whether you're right, because these are quite big numbers. So look away now if you don't want to know the answers. Now, if you did look away, you won't even know that they were there because they've gone now. Oh, the owl's back. I have no idea if there were owls in Rome. I'm in Rome at the moment. I'm looking out my window and I can't see any owls. So clearly there are no owls in this part of Rome at the moment. So currency. The money in Rome. It used to be aureus. And they were made of gold. And then it was denarii. And they were made of silver. And then it was sestertii. And they were made of bronze? I want to say bronze. And sestertii took over from bronze asses. And it used to be bronze asses and aureus. But they replaced the aureus, which was the gold, and realised they could just use paper. So solidi, or one of them is a solidus, was just a paper money, a bit like we have £5 notes and £10 notes. They had paper money, and the paper money said, this paper is worth 12 denarii. And sestertii, the denarii was worth 4 sestertii, or one of them was called a sestertius. But in Rome, they often used to plural words once you had more than one of them by putting a double I on the end. So let me talk more in my studio of how we can do some stuff on currency. Let's collect all this together and get rid of it, because we're going to talk about currency. So if I've just told you that we had these 3 things, we had a solidus, need to actually write it down. We had a solidus. Oh, you probably want to see me. Most people do. Solidus. We had a denarius. And we had sestertius. And we know that one of these, there are 4 of these in one of these. And there are 12 of these in one of these. So how can we work out what one solidus is in sestertius? Well, this is currency conversion. I am so busy talking about currency conversion, I forgot how to spell. This is currency conversion. When we want to convert currencies, I always use the same system, where even whether I'm doing euros and pounds, even though they don't exist yet, so I don't know how I know about them. So to turn one solidus into sestertius, we need to do, I think, a stepping stone. I think I'm going to use solidus, I'm going to put an S. Denarii, I'm going to put a D. And I'm going to put an E for sestertius because I've already used S. I think I want to turn solidus into denarius and denarius into sestertius. And to do that, 1 gets times by 12 to make 12 denarius. That was quite straightforward because that's the conversion we've got. But 12 gets times by 4, so we get 48 sestertius in one solidus. So 48 sestertii, because that's plural. Well, what if it's a different number? What if I have 5 solidus? Well, I take my 5, and I'm going to still times it by 12 to make this one, so it's 60, and then I'm going to have to times it by 4, is going to be 240. What if I want to work backwards? Let's say, for example, I have got 96 sestertius. How could I work backwards? To work backwards, we need to do the inverses. Remember the lesson from a few weeks ago where we have to do the inverses. So to do that, we need to divide by 4 and divide by 12. So if we divide that by 4, it makes 24, and divide by 12, it makes 2 solidus, or solidi. Solidi, I think they are, when you have lots of them. So we can convert forwards and backwards using our coins, using this little chain, because we're turning 1 into 12. And as soon as you know what 1 is, you can then work out what more are. Let's do one more together. We have got, they've told us something different. They've told us we've got 300 denarius. So we want to go this way, and we want to go this way. Well, to go this way, we're going to have to divide by 12 because we're going backwards. But to go this way, we're going to have to times by 4. So we must have 1,200 of those. And think of our bus stop division from the other day. I understand if you're year 3 and year 4, this bit might be a bit tough. But I'm just showing it so it's for everyone. Divide by 12. 12's into 30. Go 2 times and pass 60 on. It's 25. 25 solidi. Solidi? I'm going to get told off by my father because he would tell me how to pronounce my Latin. I didn't do Latin when I was at school. Although I'm a Roman emperor, so I definitely did do Latin when I was at school because it's all we learned at school. So here's how we would do currency conversion. Hopefully, I am back at my ThinkPad. And we now have our currency. So, I have taught you so far today about Roman numerals and Roman numbers. I have also taught you about the currency they used. Now, the most interesting fact I can give you about currency is they used to do lots of trading in Roman times. It's currently Roman times. I'm a Roman emperor. We currently do a lot of trading in Roman times. And so sometimes traders can be a little bit underhand and they try and steal people or rip people off or try and, because we use scales to measure how much things are worth. So we use scales and we put goods on the scales and we work out how many coins. But some traders sometimes get caught with stealing or cheating people, and we don't like that. Now, to be a trader, you would set yourself up on a big table, but the table will be made of stone in the trading square. And all the traders would have these big stone squares. If my guards discover people trading badly or cheating people, then they will go up with a big hammer and they will smash that trader's table so he can't trade anymore. Now, in Roman times, breaking something was called rupta. The Latin word rupta. You might recognise it from the word rupture, which means a break. Rupta is broken. And so you may recognise the English word bankrupt, because bankrupt means the bank is broken. The banker is rupta. Bankrupt, broken bank. And it all comes from Roman times when they used to literally break the tables if the traders or the bankers had been trying to swindle money. So there we go, a little bit of information for you. So here's my challenge to you. Complete the maths sheet that you can find in the description below, and you will find out all sorts of information from this video. If you need to rewatch it, do ask questions in the comments below the video. The more comments I have, the more I will interact with you. I'm more than happy, and they'll stay there forever, those comments, and I'll make sure I answer any comments on any videos. The other thing I will request, at the moment, we have 49 wonderful, wonderful students. I will check the comments in a second. I've got 7 likes. Can I persuade, if you have enjoyed learning about Rome, then maybe consider liking it. Hopefully you are all understanding what's going on. This is year 3 to 6. There is stuff for year 1 to 3 going to be going on this afternoon, and there's year 5 up to year 9 in about 40 minutes. Hopefully we've learnt something today. Hopefully you've enjoyed yourself. I'm doing my best to make it interesting. So, if you have any feedback, let me know. If you have any questions, ask me them. I try and answer them. I will try and put answers up for the currency things, and I'll try and let you know and post those as quickly as I can. But the Facebook group as well is a good place to go. I have been Mr. Harris. Once again, thank you so much for joining me. You are all wonderful. I look forward to working with you again tomorrow, where we're going to be learning all about discrete and continuous data. How exciting.